In this lesson, we are going to talk about the derivatives of inverse functions. So some things to remember about inverse functions are that f composed with f inverse of x equals x, which means that inverse functions undo the function. Okay? It is also true that f inverse composed with f at x equals x. So when you compose a function with its inverse in either order, you're going to get x. You get the same input. We also know that the graphs of inverse functions are a reflection of the original graph over the line y equals x. Okay, so the graph of a function relates to the graph of its inverse function. They have the same basic shape. And this is how we get the relationship between the derivatives of inverse functions and the derivatives of our original function. So the formula for the derivative of an inverse function is the reciprocal 1 over the derivative of f at x composed with f inverse of x. And what this comes from is the chain rule. So take a moment and pause and write down this formula. The derivative of the inverse function is 1 over f prime composed with the inverse function. And here I'm going to show you where this formula comes from. So we know that f composed with f inverse of x equals x. That's just what it means to be an inverse function. Then we're going to take the derivative of both sides. So on the left-hand side, we have to use the chain rule. We have the outside function is f at x, and d out equals f prime of x. And the inside function is f inverse of x. And d in, I don't know what that is, but the notation for that is f inverse prime of x. That's the derivative of the inverse function. On the right-hand side, so now when I do the derivative on the left-hand side, let's start there. Let's finish up the left-hand side. The derivative of f composed with f inverse is f prime at f inverse of x, which is the derivative of the outside composed with the inside, multiplied by the derivative of the inside, which the notation for that is f inverse prime of x. On the right-hand side, we're just taking the derivative of x, and the derivative of x equals 1. And so now, dividing both sides by f prime at f inverse, we get the derivative of f inverse is equal to 1 over f prime composed with f inverse of x. So that is where the formula comes from. You can just memorize this formula, but if you forgot it, remember that it comes from f composed with f inverse equals x. So now let's look at an example. Let's let f at x be the function x plus 2 quantity cubed. And here is the graph. It is the cube function that's been shifted to the left 2. And in orange is the graph of f inverse of x, which is a reflection over the line y equals x. And we are going to specifically look at the tangent line at the point 0,8 on f at x and the 0.80 on f inverse of x. So here's our tangent line at 0,8 on the original function, and here's our tangent line on the inverse function at the 0.80. Remember, inverse functions, we switch x's and y's. Notice that both of these tangent lines have positive slope. Okay, this is always going to be true. And the slope on f at x at the 0.08 is fairly steep, and the tangent line at the 0.80 on f inverse of x is fairly flat. The slope of the tangent line to the inverse function is the reciprocal of the slope of the tangent line on the original function. So f inverse prime at 8 is 1 over f prime at 0. We can find f prime at 0 by first taking the derivative of x plus 2 quantity cubed, and we can get its derivative by using the chain rule, and we get 3 times x plus 2 squared. Plugging in 0 for x, we find that the slope of the tangent line on the inverse function is 1/12, whereas the slope on the original function is 12. They are reciprocals of each other. The slopes are reciprocals of each other. So let's do another example. And this one we won't do any graphing. Let's let f at x equal 5x plus 1. The point that we're going to focus on our original function is the point 1, 6. Evaluate the slope of the tangent line on the inverse function at x equals 6. So this will be at the point 6,1 on the inverse function. So this is the slope of the tangent line to y equals f inverse of x at the point 6,1. I think I'd rather write at 6,1 instead of just saying x equals 6. So at the point 6,1. So the formula says that this is 1 over f prime at 1. Well, what is f prime at x? That just equals 5. So f prime at 1 also equals 5. And the slope of the inverse function is 1/5. And that is how we find derivatives of inverse functions. The slope or derivative of y equals f inverse of x is the reciprocal of the slope of y equals f at x. The derivative of f inverse of x equals 1 over f prime composed with the inverse.